Hello mathematicians, thank you for joining me today as we look at trying to draw Venn diagrams to represent sets given each of the intersections and unions thereof so we can figure out where all of the elements go. So what we're going to have here is we're going to have four sets in all. We'll have A as 1, 2, 4, 5, 7, B as 2, 5, 6, 7, 8, C as 1, 5, 7, 8, and our universal set's going to be all natural numbers between 1 and 10. And what we want to do then is draw a Venn diagram which shows all of these intersections and unions properly. Now, the first thing I'm going to notice is that as this is a universal set, everything's going to be contained in there. So I'm going to represent this just giving a big box, which I'm then going to draw everything else in. So my U is going to be the white box. Now that we have U drawn, I'm going to draw in my A. So I'm going to denote A as a circle within U because, again, U is the universal set, so A needs to be completely inside of it. And so I'm going to say this is A. And now within A, I'm going to have 1, 2, 4, 5, 7. So each of those elements need to end up in the circle of A. Now as I continue with this, I'm going to look at B next. And so B is going to be another circle. And so what I want is B is going to be contained within U, so the circle needs to stay within this rectangle that I've drawn here. And some of B is going to be the same as A and some isn't, so I need to draw a circle that intersects the A circle, but also has some stuff outside the A circle, so I'm going to denote this as B. Now within B, I'm going to have the elements 2, 5, 6, 7, and 8. So I need to make sure each of those elements is within that circle. Now notice here that I have written some of the elements twice, and so I want to be careful about that to make sure that everything ends up in the appropriate spot. And so what we see is that 2 is in A and 2 is in B. So I need a 2 in the A circle and I need a 2 in the B circle. But since 2 is in both of these, I'm going to remove it from these sets and I'm going to put it in the intersection of the two. Now we have a 2 is still in A, a 2 is still in B, and then we just have to write it once as in the intersection. I'm going to do the same thing with 5 because we see a 5 here and 5 here. And a 7 because we have a 7 in both of them. And so what we end up with is we can denote A as we still have 1, 4, 2, 5, 7 in A. In B we have 6, 8, 2, 5, 7. But now we've properly put 2, 5, and 7 in the intersection of A and B. Now, the next thing we're going to do is draw C. And so when I'm drawing C, I want to make sure that it has intersection with just A, intersection with just B, intersection with both, and some on its own. So we're going to draw a circle so that it intersects B, it intersects the intersection of the two, and it intersects A as well. And so now we have a circle for C. Again, I'm going to write 1, 5, 7, 8. And I should be careful here, I put 7 in the intersection, but I'm going to make sure that that actually happens. So I'm going to rewrite this as 2, 5, and 7. Now, as I work through this, I'm going to do the same thing, just one pair at a time. So in A, I have 1, 4, 2, 5, 7. And in C, I have 1, 5, 7, 8. So notice that there's a 1 here and a 1 here. So I can erase that and put a 1 here. Now there's a 5 here and a 5 up here. So this 5 is going to have to be in the intersection, but it's also in this one here. So what we get is that, okay, this is in A and B and in C. So as I delete these, I'm going to then put it in the intersection of this intersection with the new intersection. So 5 is going to end up in here. Now, we're going to do the same thing and move on to 7, and notice that 7's here and 7's here. So we're going to do exactly the same thing with 7, and I'll put 5 and 7 in the intersection of this point and C. So we get 5 and 7 are in A, B, and C. So I'll make the 2 a little bit bigger. And we'll erase that 7. And now we check the 8. Notice the 8 is not in A. However, the 8 is in C. So because the 8 is in C, I can erase it from both of these portions and put it in the intersection of B and C. So now I have 8 in B and C. And so each step along the way, I'm going to make sure each of the elements that needs to be in each of the sets is, and that then they're in each of the appropriate intersections, so I can erase and then move on to the inside where is needed. Now the last thing I need to do is to figure out what's left in U. So notice that U has to contain all of the integers between 1 and 10, and so I just want to go through and see what's left. Notice that I already have a 1 in U, I have a 2 in U, I don't have a 3 at all, so I need to put a 3 in U. I have a 4, 5, 6, 7, 8, I don't have a 9, and I don't have a 10, so I need to put both of those in U. And then again, 3, 9, and 10 aren't in A, B, and C, so I want them outside of it, but still inside of the rectangle. So now I've drawn a Venn diagram, given A, B, and C with their intersections in my universal set U, including all of the numbers where they belong. Thank you for joining me today. I hope you found this video helpful. If you did, make sure to like the video and subscribe to the channel.